I'm Ashraf, and I will be taking today's session for DBT. This would be an introductory session on DBT, ETL, ELT, and yeah, like basics of what is DBT and why we would be using it, and the basic of ETL and ELT. So let me start. So this would be our key learning outcomes. This is not for today, and this is for the whole course. So we would be doing the introduction to DBT. Uh, Here I will explain you how DBT works, why it is used, and like how you can use it to optimize your data pipelines and add the test and different things which can help you with the reporting and analysis of data. Then we will be going to set up the DBT environment in the local and also in the cloud, like how to use it in cloud. Then how to write the DBT models in SQL. I will explain you later what models are. Then the data testing, what test cases can DBT provide, like how many types of test cases we can use and how to create custom tests, all those things we will learn in data testing. Then basic documentation of data. Then we will go to the version control through Git and management, and then the deployment, project optimization, and all. So first of all, like who should use DBT? So DBT is basically a tool which is used for transformation of data. It is part of, you can see, ELT or ETL. I will explain you later what's the difference between both. So most of the time data engineers use it because data engineers create the data pipeline, do the transformation of the data and all. Yes. Then BI developer also can use it because you can create the reporting layer through DBT. And BI developers are the one who basically knows what data should be there in the reports and all, so they can add their specific test on that data so that the data which is coming to your dashboard and report should be as per expected. Then data architects, basically the one who design all the data warehouse and how the data pipelines would look and all those things. So they can utilize DBT for the scalable models or modular architecture. Then data analysis, it's similar to data engineer, but data engineer's role is to just give the data. Analyst basically define like what data they need and what transformation can be used for to get that specific data and what in specific format the data would be required. Then data scientist basically comes on top of this hierarchy, and they can use it for the high quality data or consistent data. They can create the test cases and models and all those things to get the data. So most of the folks who works on data should use DBT. You can see the lineage, you can see the pipeline through DBT, what transformations have happening in the DBT, and what tests are running, what test cases you can create. So all these things we can, a person who is working on can use DBT. Then what is DBT and why should we care? So first of all, let's come to ETL and ELT. So what is the difference between both? If you see, ETL is extract transformation load, ELT is extract load transformation. So what is the main difference between these two is that the like when the transformation will happen. So first of all, let me explain what is extract. So usually in data pipeline, we get data from some sources. Sometimes we get it in a form of file, which is arriving into our cloud location. Sometimes it's a file which is in SharePoint or maybe in S3 or maybe in some other places. You have those files. Files is being created by different teams. It could be some transaction database also. It could be some teams which are manually doing the input on some data. or it could be a tool through which we export the data. So there are different kinds of files, and we can use those files if we want to use the data of that file in a tabular form and then do some transformation on it. We use extract. Then there could be APIs. So there are various companies which provide their APIs through which we can pull the data. So that is also called extraction. We will pulling the data from different APIs of different companies or systems. So usually there are different tools to do that, or developer can create their own code to pull the data. Company provides their documentation for the APIs. Using those documentation, developer can create a code which can pull the data. So that's come under extract. So extract is basically extracting data from sources. It could be anything. The database also, it could be file system also, it could be APIs also. In extract, what we do, we get the data. Now, the data which we are getting it, there are like we can put that data in some cloud file source, maybe S3 or in Azure file system, ADS basically, or in some other places also. So that is called extracting. So extracting data from sources and putting it in our specific locations. Then comes a part which is load. So you are extracting the data. Now, if you want to load that data into data warehouses, it's called loading. So in case of Snowflake, Snowflake provide various features to load the data. We can directly connect to S3 through external tables. So REST and Snowflake provided. We can use the copy command to load the data from S3. We can create a code which can run on Glue or our local system, and which can help us to load the data into Snowflake. So after loading the data in Snowflake or Redshift or any data warehouse, that layer is called raw layer. Basically, we have the raw data. So raw data could be like usually what happened that the companies which provide data provide us in different files based on their how their system is designed. But the data which we are getting is not actually what data analyst or data scientist or BI developer needs to show in report or dashboard or do the analysis on that. So that's in form of different tables, and we like they need a combination of all tables by joining different tables by applying some specific logic on their data. Then it become useful. So to do that, we need transformation. So transformation is basically transforming data into something which is useful. So it could be a report, it could be dashboard, it could be some other file tables for doing the data analysis. So what happened? There are two ways we can put the transformation in this pipeline. Once after, like when we extract the data in form of files, we can do the transformation and then load the data. In other case, ELT, we extract the data, we load it first into a data warehouse and do the transformation. The difference in both is in case of ETL, we would need a different tool or we would need a computing environment to basically transform this data. And then we will load the data into the warehouse. In case of ELT, the data is first loaded into the warehouse and then the transformation happens on the data. In both cases, different computing environments are used. In case of ELT, the warehouse computing environment is used, data warehouse, whatever the data warehouse provide, the executor nodes that is used to transform the data. In case of ETL, the computing environment, which it could be AWS, it could be AWS Glue, AWS Lambda, EMR, or any other EC2 service instance where we can run our code. So the developer needs to create the whole code for connection and everything, and then do the transformation and then load the data. In case of ELT, it's just data. We load directly data into Snowflake and Snowflake or Redshift or maybe any other data warehouse, and then do the transformation on it. So how this modern data stack diagram work, like what exactly happens in case of DBT. So what we do, we follow ELT in DBT, extract, load, and transform. So DBT don't have its computing power or anything. So DBT only uses the resources of the data warehouse to do the transformation. So what happened? We have different data sources, file source or database or APIs. Then we can do the data ingestion. It could be through any tool like Airbyte or Fivetran, or it could be through the Python, PySpark scripts through which we can like get the data from some system, extract it, and then load it into data warehouse. So it's basically centralized storage, and it could be Snowflake, it could be Redshift, it could be other Postgres based warehouses. Then DBT comes, DBT basically transform the data. So data processing and transformation happens. And then this data can be used by analytics team or BI team to visualize, analyze the data for insights to create the dashboard or reports. So before like transformation is not something which DBT introduces. It's always there. We do the transformation before DBT also. But there were some challenges when we use like traditional data transformations, like script. We are using some Python script to do the transformation. There are different types of challenges which DBT overcomes. That's why most of the company prefer to use DBT instead of creating different scripts pipeline for the data transformation. So first of all, what are the challenges? So number one would be the lack of version control. So usually it's not like we cannot add the version control. Git is always there with DBT and with traditional method also. In traditional method, we can create the script, deploy the script, and keep the script in Git also. So we will have the version control, but it's not that easier. In case of DBT can directly connect to Git. So we don't have to specifically deploy the code in Git. You can directly change the code in Git and it will be reflected in DBT. You don't have to do the CI/CD on Git. You just need to create the connection. In DBT, we have option for Git, and then you can directly do the changes. So it's much easier. It's not like it's not there, but it's there, but it's much easier. So in traditional, we have to add a different step because we have script in our local or in our computing environment, and we have to move the script to Git. Or whenever we want to change it, we have to take the script from Git, do the changes, and then again move the script, move the changes to Git. So that is adding a new process to that. But in DBT, we have it inbuilt. It's like basically just a connection which we need to create, and we don't have to do anything else. Then scaling difficulties. So, like, what if we have very large data set? So, with traditional data transformation, sometimes happen if we have very large data set, we have to provide that computing environment. If we don't have, then the job will take hours to complete, and it's very difficult to scale it. If we want to run 5 or 6 pipelines, it's very difficult to do it. In traditional, we should have those resources to do it. So it's much difficult to scale in traditional data transformation as compared to DBT because DBT directly uses the resource of data warehouse. And most of the data warehouse like Snowflake and all provide parallel computation. So it's much easier. They are much faster and we don't have to manage anything. With the traditional data transformation, we have to manage the script. If we want to scale something, we have to change how it will use the executor and cores. If we are using glue, we will change the worker type and all there. If we have a bigger data, or if also smaller data also, we have to manually do the changes. But in case of DBT, it's auto scalable because we are just using the resource of data warehouse. Then the manual testing burden. So basically, testing usually what happened earlier, like with traditional data transformation, the developer needs to create the unit test cases, and sometimes we need a different test engineer to do the testing on that data. And it was like quite tricky part because there were nothing inbuilt. So the testing code needs to be created, the unit test needs to be added, and those are like proper coding. So it's quite difficult. We will need more experienced individuals to do that. But with DBT, like it's very easier. It's just the basic setting. So DBT provides two types of test cases usually. The inbuilt ones for not null or unique constraint. All those things are just the basic setting. You just need to put some values and the test is ready. So all the testing, like how to do the testing and all DBT manages, we just need to create the basic tests. And usually if we need to custom test, we can just create it using SQL. So no other language is required. No expertise in Python, PySpark, or all those things is required to do in DBT. In traditional data transformation, usually it could not be achieved without the knowledge of scripting, any scripting language. So it's much easier and it's very fast as compared to old, and like it's all automated. So it's not like we have to do the manual because sometimes what happen in traditional data transformations, it's very difficult to create test cases. So usually what developers or testers do, they do the manual testing on that data. When it comes to data warehouse, they used to do manual testing. But now you can create all the test cases because manual testing also they would be doing through SQL. So they can use the same SQL to create the custom test cases. So instead of doing all the manual testing, which used to happen earlier on the data warehouse, you can create the test for it, and that test would be automatically running. DBT automatically create the lineage dependency on the test and the models. So it's all automatic. Once model will run, the test will run automatically. So I just told you there is no programming language barrier. You don't need to run new languages. You don't have to be have ex, like experience in Python or any other language. It does not require those long Python scripts. You don't have to manage the resources. If you're using PySpark, you don't have to manage like what would be the like how much data would be a worker node would be using or how would data be distributed. Everything is managed by data warehouse only. So there is no use of there is no need of a new programming language. Just SQL is enough. So any data analyst or BI developer who knows SQL can use DBT easily. So what is DBT? Let's start. So DBT is basically data build tool, the short for that. It's an open source tool. So open source is you can download it and use it in your system. When you need DBT cloud, then you have to pay it. Or if you just need to use it in local system, you can directly use it. So it's an open source tool that allows data analysts and engineers to transform, test, and document data in a cloud data warehouse using SQL. So you can do transformation, you can do testing, and you can document the data. And all these, like with the introduction of DBT Copilot now, I think some 2 3 months ago, DBT added DBT Copilot also. So it's much easier to do all these things now. You can just directly ask Copilot to create the test or document the data or create the model for transformation. So what basically is true, whatever raw data we load into the data warehouse, the initial unprocessed data, DBT models create, like we create the DBT models on top of that data a- and do or write all logic in the DBT models and do the transformation. And then this clean, refined data would be ready to use in Tableau, Power BI, MicroStrategy, any BI tool, or can be just used for the data analysis by any analytics team. So, what like are the like real power of DBT? Like why we are using DBT? So, what happened like before DBT? I told you manually write and maintain long queries every time you need a report. So basically, if you need to create a report, you create a long queries, list of long queries with different joins and all, and you run that query, you get that data, and then you use that data for reporting. Or in Tableau or BI, you put that whole query and do the reporting. And it usually take time also to running all those query. If it's a very long query, it will take lots of time to run it. With DBT, we can break that down SQL logic into different models, and then we can just join those models to create a. So it's like creating table out of that. So doing the transformation and creating different tables, and then joining those tables to get the data instead of long queries. We can do that. Then Jinja is basically the template which we use in the BTR project. So, like when we first set up the project, we need to set up the whole directory with projects and different file which are required. I will explain you more about this in detail in later sessions. So, a folder structure is required. We need to provide some models in a specific model folder, then test. There are different YML files and all. So most of the files which we use in DBT use a Ginger template. So I will explain you more about this Ginger template, how to write it and how to use it. We can use all the if loops and all those things in macro. Macro are similar to SQL functions, or you can say procedures and all. Similar setup of different environment. So in same DBT, you can create different environments, dev, QA, test, or production, and then you can run the same query, same model on different system based on like you can change it from there, or by after deploying you can run those models and all in different systems. So we will be learning more about this in later session. So it is something which look like this. So if you see the configuration we set up, this is the basic query. So I will explain you more about this in later sessions. Then macros also, I told you it's a programming functions, like SQL functions type of thing. It's written Ginger template, and we will discussing about this more in later session. Okay. In test, so in DBT, I told you we can create test with just putting some values in a file, and the test is created. So you don't have to manually write a long code or something for test. Like if you see, this is a basic test on a stage table. So test is unique, like on our order ID, this test is created, then not null on order ID. So this column, let's assume you're transforming a data, and finally what data you have, you don't, you want it to be unique and not null. You have to want to apply that constraint on the column. The issue is that like you can apply these on data warehouse also, but that will fail the thing. That will throw an error. Test usually what do after the model run, test will run and it will notify you that these models have these issues. And then you can go there, check why it's coming, and you can rectify it. Version control, I told you before DBT, if it is Python uh, or any script, so it's possible to do version control on that. But if you are using any SQL file to create the reports and all, version control was not possible. Like manual version control you can do, but automated version control was not possible. We were not doing it because we were running those scripts manually at that time. But with Git, we can just connect Git dbt to Git, and we can do the version control on that. Then lineage. So what basically lineage is, like we know usually what happened that if you are doing some transformation earlier, before DBT, when we used to do the transformation. So sometime what happen in pipeline, if we want a specific report, so the report is coming from different tables when we join different tables. And those different tables could be coming from some other different tables. So these basically create a pipeline that we have some raw 5 or 10 raw tables. Then we join those tables, we create 2, 3 more tables, and then we join those 2, 3 tables, then we create the report. So now usually what happen if you want to do this transformation, you have to follow the specific pattern. When you are doing manually with queries, you have to keep in mind like this query you need to run first, then this, or you will create a very big query which will do everything. So it's very difficult to manage. In case of Python script also, you're going to create the Python script and then set up dependency for different Python scripts, because like if you're doing the transformation for different table, there will be different Python script for doing that. And then to set up dependency between two the Python scripts or like transformation script, you will need some other tool to do it, like some orchestration tool like Airflow or like time-based schedule for setting up dependency. So it was very challenging. There were manual steps needed or a new tool or like on the basis of scheduling a timing, you used to do it. But with DBT, what happened? DBT provide us lineage automatically. So what happened when we create a DBT model, we can specify that which other model this model is dependent on. And then DBT created a whole DAG for it, like whole map, like which models are depending on which model. So let's assume if we want to run a report. So whatever is upstream model are there, whatever upstream tables are there, staging tables are there, DBT create a dependency itself, and when we run it, DBT start with the basic raw, then staging and all, and in the specific pattern, it do it automatically. So you don't have to define it. So you get automatic lineage, and you can virtually track like how the data is moving from and how models are running. So we will discuss it more about the lineage because this is one of the main part of DBT, and this is also used for backtracking the issues and all. So we will be learning about this in detail in later sessions. For performance optimization also, basically we can use DBT. Like in case of before DBT, we used to like create the queries. If there is a single query which is using data from raw layer, so it used to be a very big query and it used to be very slow. Sometimes it used to take hours also to complete if we have very uh, a large number of tables and there are very complex logic. We have different groups, we have different Windows functions and all, and if we are doing some transformation in that query, so that used to take a lot of time. But with DBT provided different types of models. We can break it into different models and then run it based on our requirement. We can create the views, we can create the tables. There are ephemeral tables also, which are internal tables, and there are incremental models also. We will learn all about this in detail in later session. So we can use all these different types of tables and models to optimize our queries. So basically, benefits we already discussed. So first of all, it is SQL based, which is like SQL is much easier as compared to any other programming language. It's just the basic English. So I think anyone can learn it in 2 to 3 months max. So if anyone knows SQL, they can use DBT. There is nothing else you need to do to use it. There are basic templates. So you just need a basic configuration and then start writing the SQL. Then it's more modular and scalable. We have different models. We can scale it. We already discussed it. Then version control, same Git. We can use Git. We can do the version control on the DBT. Then automated testing and documentation. These are the main benefits of using DBT, and this is why we use DBT. So this is difference. So version control, basically no version control is for SQL. So if you are using in the traditional data transformation, if you are using just different SQL queries, so version control is not possible. But in DBT we have that. Then automated testing, manual. In traditional, we used to do manual testing, running the queries, comparing the data and all to do the testing. So every time a new pipeline is created, you do the testing manually, but you can't do it like daily or something. So with DBT, there are automated test cases, testing, which happens whenever the model run. So it's much better. Then documentation. In traditional, there used to be like no documentation. If we want to create a documentation, we create it separate in Confluence or some other uh, sites or in form of some Word files and all those things. But in DBT, it's very easier. You can see all the documentation there only. Then scalability. So it's highly scalable as compared to the traditional transformation tools. Then we already discussed about modularity, and so it's more modular. Then we have two DBT products, usually DBT Core and DBT Cloud. We will be discussing about both in detail. DBT Core is for our local. We can use it locally on our system. DBT Cloud is which we can access from anywhere. So it's present on the cloud and you can run all your models and all on the cloud. It provides a basic UI and through that you can use it. So what is the difference between DBT Cloud and Core? So first of all, the interface difference. DBT Cloud, I just told you, it's a web UI. So you just have to log in, and just use it. It's a UI. You can write the code there. You can run your job. You can run the model. You can create the test cases. Everything you can do on web UI. In DBT code is CLI based, so it's command line. You have to write the command for DBT, running the test cases and all those things using the command. You have to create the connection and all through command. So that's basically CLI based. Execution, DBT Cloud is managed by in the cloud. DBT Core runs locally on the server. So as DBT is open source, you can use if you want to use it locally, you can use DBT Core. If you're using it, if you want to use it like anywhere, if you don't want to use your local system resources, so you can use DBT Cloud. Then scheduling. In DBT Cloud, we have built-in scheduler, we have jobs, we can schedule the jobs on the basis of time, or we can use any orchestration tool also. Using API, we can trigger it. So it's like we have built-in scheduler and we can use the orchestration tool also. In DBT core, basically external scheduler would be used like only Airflow and all you can use, or you can create the cron locally. But DBT Cloud is much better as compared to DBT Core because if your system or local server is not running, the job will not run. In case of cloud, it's always online, so you just need to provide the schedule and it will run on time. Authentication, it's basically to log in, so it's SSO based, it's handled manually, so it's more secure. Case of dbt cloud, dbt core is just manual. So then version control, git, but in dbt core is also git, but you have to manually configure it. And as I told you, in dbt cloud we have the setting. We can just uh, there is a setting for git, we can just mention our git details there, and it would be automatically connected. Cost, I told you dbt core is open, dbt is open source, so you can use dbt core without any cost. It will use your resource, it will use, you have to manage it, but yeah, it's free. When you are using dbt cloud, it's a paid service because they are like making it online all the time. You can access it from anywhere, so it comes with some cost. Yeah. So let's discuss about the basic data, basic architecture of dbt cloud. So dbt core, it's a open source, it's just a code, so like no architecture is needed. You can, like, you will be using your resources and all. In dbt cloud we have a cloud application. There is a ID. You write the SQL, it will compile your code, it will check if there is any error or not, and you can run your SQL there, your code there. So it's a ID services, scheduler services to schedule your model, your jobs, like whatever the dependency you have in model, you want to run all those models. So you use the scheduler service. Then there is a semantic layer, and there is a Postgres, like inside, to keep all the info, like whatever the job you create, so it have to keep all this information somewhere, and whatever models you are creating, so all those dependency information you have to keep somewhere, so that is Postgres, it's database. So through the public internet we can directly access dbt cloud from anywhere, and this is connected online through git and data warehouse, so you can connect it from Snowflake, and then dbt cloud will be connected to Snowflake. You can directly connect to dbt cloud through internet, and whatever you do, whatever transformation you do will automatically goes to Snowflake.